Hello everyone, in this video I'd like to show this demonstration how can we set up the Ethernet CIP communication between Siemens S7-1200 PLC and Allen Bradley Micro800 PLC. And in this test I will use Siemens 12-14 this controller, and Allen Bradley side I will use Micro820 this controller. So the Siemens 1200 series controller and Allen Bradley Micro800 series controller are widely used. So it's very common to see both controllers worked on site, worked in a same plant. So I think it's a value to discuss this communication method. And Siemens and Allen Bradley, both series controllers, they all have a built-in Ethernet port. So in this test, the Siemens S7-1200 PLC will run as a CIP client, and Allen Bradley Micro800 or 820 will run as CIP server. Basically, the CIP server side do not need to do any special setting. It's just waiting there, waiting for the client try to connect and fetch the data or send the data. So the Siemens side, we will set up the connection and we will program slightly to send the data or fetch the data. And from the Siemens side, I will use TI Portal version 17, that is the latest version. And Allen Bradley side, for the Micro800 software, I will use the CCW, the latest version, version 20. And if you recall, in 1 year ago, I showed one demonstration setting up the Ethernet IP CIP communication between the Siemens S7-1200 PLC and Allen Bradley Compact Logics PLC. This example version, that version 1.0, that didn't support the Micro800 communication. But now, its latest version, that is version 1.01. This version supports the Siemens communicate with Micro800 series controller. And in this case, Siemens side, I will use TI Portal version 17, this latest version, and I will use the example project. I will copy the example project and paste. This will be very quick to set up this communication. You will see this progress. And Allen Bradley side, I will also use the latest software, Connected Components Workbench, the CCW software. And I will use the free version, and I will connect one real controller. This is the Micro820. Okay, this controller, Micro820, it has one built-in Ethernet port, and I will set up the Ethernet communication between this controller and the Siemens S7-1200 PLC. If you are the beginner or you are not quite familiar with this communication, I would recommend you can download this example so you can just change a little bit associated with your hardware. Okay, I will use this example project. Okay, let's download and let's open this example project. And this file, that's the version 17 compressed project. So we can use the TI Portal version 17 and open this compressed project. All right, let's select the open this compressed project. And let's open this compressed project. Okay, after we open this project, we will find it supplied three types of the controller: 1200 PLC, 1500 PLC, and this is soft PLC. According to your current PLC, you can select one of them. For example, in this case, I'm using 1200 PLC. That's the 1214. So I can use this, and I can copy this project and paste. And the reason why I pick this rather than this, because when I try to replace the controller, so the system will only point to the 1200 for this one. And for this project, the project will only point to the 1500 PLC. So if we open this, we will see this project includes a CIP client, so that actually comes from the library. In this OB1, we will see a programmed something, so it saved the time for us to starting from the scratch. So as we can see here, this is the IP setting and this is the function block. Okay, so we will copy this one, copy and paste. Okay, we paste the project here, and from this project here, we can rename this project EIP CIP Client. That communication will go to communicate with 820, okay, Micro820. So meantime, we can delete others. So I can delete other projects. And from here, we can replace the hardware, go to the device configuration. And from here, we can right-click, click this change device, change the hardware you are using. So in this case, I'm using 12-14 DC-DC controller. Okay, and I know my controller, the version is version 4.4. So keep in mind, the controller you are using must above the version 4.2 according to the manual, okay, to use this feature. Okay, this is my PLC firmware version. Okay, click OK. All right, and after this, let's go to the Ethernet port and let me configure the Ethernet IP address for this controller. I will activate this subnet and I will configure the IP address. So because we copied from the project, so that's why it has one existing IP address. Okay, doesn't matter. We will change this IP address to 192.168.1.181. This is my Siemens PLC IP address. Okay, and the subnet 255.255.255.0. The only things we need to configure, this is the IP address. And one more thing we just need to keep. Let's go to the system constants. And from here, we will see the port from the Siemens system. Every port has one hardware interface ID number. The ID number, that's a 64. This is the hex number. The decimal number, that's the 100. And when we use the function block to point to the hardware port to assign to the function block, so we need this number. Okay, then let's go to the program. Go to the OB1. Okay, as we can see, this is the project we copied from the example. So in this portion, this is the target. This is the target CIP server. In this case, the target is the Micro800. The IP address is 192.168.1.198. Okay, in my demo kit. Okay, so we will assign the IP address 192.168.1.198. Make sure we assign the correct IP address. So we will see this target area. The target, actually, that's the instant DB of this area, DB1. So this is the core portion, the function block 1, that named the LCCF CIP Client. This run as the Ethernet IP CIP Client. Okay, so we assign the server IP, and then we need to assign the hardware to this function block. As I showed, the Ethernet port, the hardware, the ID, that's a 64. So from here, we can click. Okay, after we click this, we can assign this interface 1. This interface 1, that behind, that's a 64 here. Okay, and the tag, this tag is very important. Currently is connected to this DB, the tag list, this DB2. And if we open the tag list, this DB2, from this example, it prepared 3 variables at here. This area that's used for point to the variable or the address from the target PLC. In this case, the target PLC, that's the Allen Bradley Micro800 PLC. So this area, we need to type in the variable name. Also, we need to assign the tag type. So we need to review the manual. We can temporarily leave this area here. There are also some important variables we need to assign. Firstly, this is a slot number. Let's go to the manual. Let me point to if we are going to connect the Micro800 PLC. For this slot number, what the number we need to assign at here. Okay, if we open this manual from this ID, to check out the manual, you need to go to this application example and open this PDF manual. Okay, and after you open this manual, go to the page 14 and you will see this description here, the Micro800. This is the key difference between the example version 1.0 and this is version 1.01. This is the key improvement. So for the Micro800, we need to assign the 127, this decimal value for that slot number. Okay, this is the key difference. All right, now let's go to the program. If we are going to communicate with Micro800 PLC, so the slot we need to assign 127. So we can write the 127 at here. And then for this function en and for this enable, we can assign the two bool. For example, at here we can assign the M10. And we can rename this tag to IP1 en. Okay, and assign this communication enable to M10.1. Name that CIP Client enable. Okay, after we assign this enable and 127, there's also one important parameter. This is the update rate, especially for this small size controller. Basically, if we leave the 10 milliseconds as the default, that is a little bit of challenge for this too small controller. Personally, I would recommend you set this update rate higher than 200 milliseconds. Typically, I will use 500 milliseconds. So temporarily, I can set 200 milliseconds at here, but when I tested that, I found 500 milliseconds could be a stable parameter for the communication. And then we assign all the things that are important for the left side. Right side, because this is the instant DB, so we can still see the output here. And then let's focus on this tag, this DB. Let's open. So firstly, from this example, it assigned 3 variables at here. We can change this number. For example, we can change to 6. So 6 here means totally it has 7. It starts from the 0 and to 6. So totally we have 7 variables. That means we open 7 variables ability for this DB. Okay, once we start up the communication, so this controller running as a client, so it can communicate with 7 variables behind. And when we open each of them, so we'll see at here we need to assign the tag name and the tag type. Tag write and the value, this looks a little bit confused. To clarify this, let's firstly go to the micrologic side. Then from the micrologic side, we will see and what the tag name we need to assign at here. So basically for the client side, we almost complete. The only things we need to assign, this is the variable name and those tag and the tag write. Okay, so let's temporarily save and let's shift to the Allen Bradley Micro800 software, that's CCW software. And the current controller, what I'm using, the Micro800, this 2080 LC20 from Allen Bradley. Okay, so this small controller that has one built-in Ethernet port. It has the Ethernet IP CIP communication. Okay, and from this case, I assigned the Ethernet port for this controller 192.168.1.198. This is the IP address for this PLC. Okay, and then I programmed a very simple logic. So if we go to the program here, and we can see this is a very simple latch-in logic, and I control the digital output 0. And I use this bool start push button to start up this output. And I can use this variable bool stop push button to kill this output. In the meantime, I create 2 integer variables, integer 1, integer 2, and a real 1, real 2. So if we go to the global variable list, double click this global variables. If we scroll down, and we will see those are all the variables I create. So they are bool start, push button, stop, push button, integer 1, 2, and real 1, 2. And take care this date type. So those variables we will use the Siemens PLC to read or write those variables. Okay. Now, let's download this controller. So let's connect this controller. Okay, we connect this controller and let's download our logic to this controller. Alright, we download this logic. Alright, we download this logic. And from this online status, we can see if I toggle this variable, so it can fire this output. And in the meantime, we can see this is the output. That orange indicator shows the output 0 that fired up. Okay, if I toggle this stop, firstly I will turn this off, and if I right click or use the Control T, if I turn on this, it will kill the output. Okay, it's working. And from this integer calculation, I will add 1. So if I use a Siemens controller to write this integer 1, so we will see the integer 2 will be always add 1 based on this integer 1. Okay? And for this real value, it will always add 10. If I use a Siemens PLC write some value to this real 1, the real 2 will be always add 10 after that. Okay? So now let's shift to the Siemens PLC side and watch carefully for those variable name. Okay, and let's go to the Siemens side. Okay, so now we need to do something for this DB here. And before I change something here, I highly recommend you read the details in the menu, and especially for this tag tab and this tag write this bool variable. Okay, so if we go to the page 16 of this menu, and we will see this type code is very important. If we are going to communicate with a bool, so we need to use the 00C1. If this is integer, we need to use the C3. And if this is real, that need to be the C8, okay? And if we scroll down for the next page, and we will also see this writing. And this writing, when this writing equal to 2, that means we will write from the Siemens side to the Allen Bradley side. If that default is the false, that means the Siemens side will read the value from the Allen Bradley side. So this bool will use to control this variable we are using as the reading or writing. Okay, and this quality we can monitor that. If that shows a G, that means good. That means this variable that is qualified, the name is correct, so it's communication correctly. Okay, this is very important. And then the tag name, we need to type in the correct name associated with the Allen Bradley side. Okay, let's go there. So we can start from the tag 1. This I tend to write something wrong at here. So we'll see the quality will show the bad, the B. Okay, so we start from the tag 1. From this tag 1, we will firstly communicate with that bool B start. And watch carefully for the capital and the small case. That's the push button, okay? And because that's the bool, we will use the 6.00C1. Okay, the bool C1. And for this start push button, we will write to this tag. Okay, so we will set to true. Okay, and when we control this value, we can write something at here. Okay, then let's go to the next one. That's the stop push button. So we can write the bool stop push button. Okay, and also this is a C1, the bool. We'll copy, and also this is the C1. Okay, the bool, and we'll also write this variable. So set to true. Okay, and then the next variable we will control the integer that named int1. And the date type we need to be very carefully. This is the 00C3, okay, for the integer. And the tag write we will set to true. We will write this value, okay. This finish. And the integer value we can write the actual value to here. And next one, that's the integer 2, okay. That's the integer 2. And same thing for this integer tag type. This is C3. And this integer 2, we will monitor this variable. So we do not need to write to that because it's the calculation result. So that's why this tag write we will leave as a default false. Okay, we can also see the comment at here. True that perform tag writing, false that perform tag reading. Okay, we will see some comments at here. Okay, the next one, let's set the real value. So the first real, that's the real 1. Okay, for the real, this tag type, that's the 00 C8. Okay, and the tag write, we are going to write something for this real value. We set to true. Okay, and for the next real value, that named small case r real 2. That's a 00 C8. Okay, and for this real 2, we will monitor this calculation result that add 10 after that. So we will leave as a false. Okay, so we set some start parameter at here. We configure this. So let's download this controller, compile and download. Okay, load the program, start up the module after the download. Alright, let's click the online. So double check the IP address we are setting. So that target IP address 192.168.1.198. This IP address, this is the target Micro800 that IP address. Okay, now let's enable this function block and let's enable this communication. And in the meantime, let's watch this output. Okay, set to 1. Boom. So once this value shows true and the BC shows true and the status shows 7002, that means that communication set up. And keep in mind this slot number need to set 127. And this update rate I changed to 500 milliseconds as a testing purpose. And in the meantime, we can go to the DB2 and we can turn on the monitoring. And we can expand all of them. Okay, we can see after I start up and after 1 or 2 seconds, so it updates this status. So we will see this is the actual status. That means all those variables we set, they all correct, except this first one. The first one I left as the empty, or any other name, doesn't matter. So this empty here, that shows bad. I would recommend if you have any spare, we better leave the tag name as empty. And now we can set the bool value to here. Okay, now we will set this start push button to 1. So we can click and modify this variable and we can set to 1. Okay, we will see this 1 command sent to this area, sent to the Micro800, and it turn on the output. Okay, and in the meantime, from the real PLC, we will see this output that turn on. Okay, and if I turn on this variable, it will kill this output. So firstly, let's turn off this, set to 0. So we will see this will turn off. Okay, and then election itself, if we turn on this stop push button, so it will kill this output. Let's see this output. So let me send a stop command. Send. Okay, so it killed the output. We definitely find some slightly communication delays. That's because I set 500 milliseconds. Okay, in the meantime, let's set this integer. So we will see if I set this integer, this is a write. Okay, if I write the decimal 25, so it's showing the 19. That's because this is a hex number. So from the right side, we will see it received 25 and the feedback 26. And the 26 we read, and from the Siemens side, it read this integer 2. And from here, we can see this value shows 1, 8, and this is the hex value. The quality shows good. So, however, this hex value is really hard to read. I will explain how can we do this. We need to convert this hex value to a decimal value, same as the real value. Okay, I will show this after. Okay, and same as here. So we read something from this real 2 already, but the value shows as a hex value. However, we can send something already. So if we send, so for example, the real value, if I try to send, select the real floating point to 23.5. So we send out, and in the meantime, I can also change this integer value to another value. For example, I will send 100. Select this decimal to 100. So we will see the right side. It received 100. Also, the real value it received 23.5. Okay. So now let me shift to the Siemens side and let's program something for showing those decimal and the float point. Okay, let's firstly go offline, and then let me create 1 dB. So this data block, we can select the automatic number, so we can use the default name data block 1. Okay, and here we can declare two integer value, integer 1, data type, this is the integer, okay, and the integer 2, integer, and the real one, this is real, and the real 2. Okay, and then we can use the convert command. Okay, let's go to the OB1, the program area. Okay, to transfer the integer 1 to that tag list here, so we need to use some command. So let's go to the conversion. Okay, convert. Let's use the convert. So convert, and the left side we will set this integer 1. This is the source data, and the target, this is here, the integer 1, this value here, this one, this tag 3. So we will drag this value to here. Basically, we convert the integer to a double word. Okay, so let's see if it can select. Okay, let's select this integer to dent, okay, to here. And this is the integer 1. Okay, we can also read that integer. Okay, we can also use the convert from the integer 2, this value, the source data is here, and this target this time backward. Okay, this is the integer 2. Okay, this is the integer 1 and the integer 2. Okay, and let's select this to integer. And let's select the left side to dent, and select the right side to integer. Okay, and then let's do the real. And the real still use the convert. Firstly, this is the source data. This is the real 1. Okay, real 1 we will send to here, this tag 5, real 1. Okay, this is our command value. Drag to here. Okay, and let's use another convert. So let's read that real 2. So this time the source data, this is the real 2 value to here, the source data, and then the target to backward, and we will transfer to the real 2. Okay, the word to real. Okay. All right, now let's save and download, and let's see if this convert can run correctly. And I will disable this communication first, and let's reconnect. Okay, enable, and enable this communication. So it shows 7002. Okay, and keep in mind this slot is 127. Let's also go online to watch this tag list. And let's have a quick glance to see the quality. So quality shows good. Okay, that means all the tags they are communicating. Okay, and now let's show the parallel. Okay, I'm showing this parallel style. And now from this integer 1, I will set the value to 100, for example. Okay, 100, and we will see this time the communication faster. That's because I set this update rate to 200 milliseconds. So we will see the result shows 100 and 101. Let's set another value here. Let's set 88. Okay, 88 and the result 89. So this time shows much faster than the previous time. Okay, let's turn to the real value. So firstly, we can see this real 10.0 it read back. So it's reading correctly. Okay, now let's set, for example, 3.14. Okay, 3.14. Okay, 3.14 we can see it right here. And 13.14 read back. Okay, let's set another value. And in the meantime, let's watch this delay. 25.6. Click OK. So it's showing the slightly delay, but definitely shows much faster than the previous time because the rate I set smaller. Okay, the rate I set 200 milliseconds. It has roughly 1 second delay. Okay. Alright, this is the Ethernet CIP communication between Siemens S7-1200 PLC and Allen Bradley Micro800 series controller. And we set up this Ethernet CIP communication. Basically, the Micro800 side do not need to do any specially program. And from the Siemens side, for the S7-1200 PLC or 1500 PLC, we only need to call this CIP client, this function block. And we can also use the sample program, so we can very easily set up this communication. Alright, that's it for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.